Welcome to the AI and ML conversations with myself, Yavor Botev. In this podcast, I talk to AI and ML experts about building real-world systems, working with humans and AIs, and exploring the future of our field.
Hello, everyone, and welcome to the AI and ML conversations with myself, Yavor Botev. Today, I have the pleasure of having Yordan Madzhunkov, somebody I'm very excited about because he has all kinds of different interests and quite an in-depth knowledge in, I would say, all of them. So we'll be able to cover a lot of topics today. Hi, welcome, Yordan.
Hi, nice to meet you. Thank
Nice
you
to
for
meet you
inviting
indeed.
me.
Yeah, pleasure is all mine. I want to start with a tiny anecdote of how we know each other. It's a super funny story. I'm not going to share all the details, but yeah, somehow we ended up in the same hospital room. We were treated for some stuff, and yeah, we ended up chatting and found out we had, I would say, some things in common, at least on the mindset level, and also on the, I would say, the technical level. Yeah, so I'm
Yeah.
very, very happy about this
So we also
random
have like the
introduction.
same favorite surgeon
Yeah, exactly.
that fixed our lives, basically. Yes, so
Yeah,
that's a funny
indeed.
story, but for me it's important that it doesn't matter the context, so you can find people you resonance with at any place or stage in life. So people should be open-minded.
Yeah,
Yeah, so
indeed,
that's
indeed.
very funny.
So I was actually recently watching another podcast, and the guest there was mentioning how we should try to increase our luck surface area,
Yeah.
so that more and more interesting opportunities come our way. And one of the things I like to talk about in the beginning is actually starting from the beginning and starting from, let's say, your university years. I know that you studied physics, and I always find people who decide to study physics very fascinating because you have kind of a unique way of thinking. So maybe you can talk to me about how you decided to study physics and what was your transition to computer science like, or maybe you were
Okay,
interested in
so
the same things together.
as a student in high school, I participated in different competitions in math, in physics, and I was quite good actually, especially at later stages in high school. And I had a friend. We sit together on a same desk in school, and he was competing in informatics. So I was curious. I was like, "What you do in these competitions? How it goes?" So basically, he taught me programming on a piece of paper during 2 hours in English language. And I was very fascinated. And he said, if you know, you can come home and I will show you on a real computer. And I was like, yes, I want to do that. So basically, after school, we went at his house and he showed me. At the time, it was Borland Pascal. And he showed me the IDE. He showed me where the help is, how I can read the help, the docs. And he said, you're good to go. You're programmer now. And I was like, yeah, programmer now. And started coding. It was like that. It was like a play. It was super easy. So eventually I self-taught myself to program. I even attempted to do some funky stuff like, because you have only text console and there is not much stuff you can do. So back then I tried to develop a chatbot so I can chat with the bot. Yeah, so it was very funny, but
That was sorry for interrupting you. That was when exactly?
it was prior 2000. And
Wow.
yeah, I mean, it was silly attempt. Basically, I had like a couple of random questions. Then I prompt the user to answer, and then I pick another question, or maybe I select a random answer sentence. Yeah, it was, as I said, it was child's play, but this is how I started. So basically, by reaching university, I was self-taught programmer. And I had to make the decision either to study physics or informatics. Because I was keen in both, I was very hooked. And it was not an easy decision, but what I did is I taught myself, okay, I can continue to develop my skills as a programmer on my own. I don't need the university for that. I already had the network of friends who already study computer science in Bulgaria and some abroad. So I can chat with them. I can ask them what you do, how. Basically, I can keep track of what they're doing and do it on my own, whatever I find interesting. And with physics, it's not like that because you need equipment, you need like access to good teachers to explain you the complex models and math. Yeah, for our audience, you can imagine one piece of equipment, let's say oscilloscope, costs like $100,000. And if you want to do like any decent experiment, maybe you need a couple of those, not just one. So physics is very expensive to actually learn, especially when you go to the what's interesting at the moment. So if you think of CERN in Switzerland, and yeah, that's super expensive. So that's why I decided to study physics, so I can keep both of them as skills and potential career paths. And eventually, after I finished studying physics in Sofia, it was 4 years bachelor, I went to complete a hybrid master program in Germany, which combined both. So it has also, it was called Simulation Sciences. It has to do with computer simulations, but it also provided a very nice mathematical understanding of error analysis and how you can basically understand the errors that come from numerical precision in your computation. That was extremely important to me at the time. And I remember I was in the university, and when they showed me all these equations and math and how it works, I already had like a job as a software developer where I had to develop a video stabilization algorithm for a handheld device. And I was like, yeah, this is why my code did not work, because I did not understand the numerical precision error accumulation. And now I do, and I know I can go back to the job and fix my code. And I was like, you know, you're in a different mindset when you're like actually struggling to solve some problem, and then some teacher in university gives you the answer, and you're like, yeah. When you're just teaching the stuff without the context of the problem, you're like, why I'm learning this? This is boring. Why am I going to use this? Just to pass the exam. And that's so. In my career, I try to do. So I try to tackle problems in advance. So this will keep me motivating to learn. Yeah, basically.
Yeah. So that's very interesting that you mention it, and because from my discussions with you, I know that you have interest and knowledge both in the hardware and software related topics, and the one that you mentioned about let's say the accumulation of errors to the precision of numbers, how they're stored, I guess. This is so like it somehow, I guess this is related to your physics background, that you're more interested in knowing how things work at the deeper level. Would you say so?
Yeah. And even, I mean, in mathematics, you have this property like A plus B plus C is equal to C plus B plus A. So in computer programs, that's not true. So the order of you of the operations matter to the final result. It
Yeah.
matters also the hardware you're computing them on. So one processor can round up different than another.
Mm-hmm.
And when you throw on that some kind of parallelization, because nowadays we usually, when we multiply vectors by big matrices, we use parallelization. So the order of the operations is not deterministic because it depends which thread will take which chunk and so on.
Mm-hmm.
So this means the final result is not deterministic. So even if you run the same code on same computer with the same data multiple times, you can get different result.
Yeah.
And this causes problems in some applications. And if your program is written in such a way that is numerically unstable,
Mm-hmm.
then you have problem. So the good news that, for example, most of neural networks and their training, they're written in a numerically stable way. So people
Okay.
that do the underneath low-level libraries understand this stuff and they take this into account. So
Mm,
it's stable by
nice.
design. Let's call it this way.
Yeah. Yeah.
Yeah.
Interesting. I want to go on a bit of a short tangent on something else that you mentioned
Mm-hmm.
a few minutes ago. You said that you like to learn in advance so that when problems arise, you are able to tackle them. That's actually something that I have been debating with myself mostly, whether
Mm-hmm.
that's a good approach or not. I think, I can't remember if it was Andrei Karpathy or somebody else well known in the machine learning field. He mentioned that the best way of learning is to actually start working on problems and kind of tackle things as they arise rather than spending time learning things in case you need this knowledge. So how do you balance the two?
So actually, I do both. So I can give an example.
Mm-hmm.
Yesterday, I tried to develop a mobile app from scratch. I never did that in my life. And I spent 4 hours just failing to set up the dev environment. So it's not a success story, but it's something that I decided to do out of curiosity. So I don't need it for my job at the moment. So my future job does not require it in any way.
Mm-hmm.
So this is like explore kind of something to try. And sometimes on the job, you don't know the stuff and you have to learn it on the fly. So this is the second approach. And in computer science, I think this is called explore exploit type of algorithms. So accumulating knowledge is follows in this definition. So, and one of the optimal strategies is to combine both methods. So initially, I remember this. This is very good example. So imagine if you're like going to a city and you're searching for a restaurant to eat, and you're tourists. So you have like a limited meals you do, like let's say 10. So if you try new restaurant each time, 10 times, some of them you may like, some of them you may not like, but eventually your satisfaction will be the average level of the restaurants in that city, matched to your taste. And if you want to improve on that, what's a good strategy is basically to split, let's say, first you try 5 restaurants, and then you revisit the one you like the most. This is how you increase your expected value of satisfaction.
Mm-hmm.
And there is some complex math behind it that can actually tell you the optimal value. So how many visits you have to do of search, and then you'll start to exploit. It's an interesting task from computer science, but I actually use it when I travel. So I actually do that. Try 3 places, and then I go to the place I like the most. Eventually, if I get bored, I will switch, but that roughly never happens.
That's really nice. that you're actually using this in practice. I know
Yeah,
there
so the
is.
same is with learning. So in the beginning stage of your career, let's say in your 20s, you should learn as much as possible. Then you go to a phase like when you're like mostly applying the knowledge you already know, and maybe at later stage you just apply.
Yeah.
But that's hard to do because people that are curious, usually they stay curious all their life and they keep learning. And for them, it's something they enjoy. So they continue to do it for the enjoyment of that. And people that are not curious, in my opinion, are just people that were like, they were curious as a children, but then the school system killed their curiosity. Basically, this is what usually happens. Somehow my curiosity survived through high school,
Despite, yeah.
despite the system.
Yeah. Right. So the other interesting thing that you mentioned is being interested in working with low-level libraries and thinking right from your, I would say, master's degree or maybe even earlier. Did I guess this informed what kind of jobs you started to look for and what kind of positions you got in the end? So what were some of your interesting first positions or tasks that you worked on?
Okay,
You already mentioned the video stabilization, which is definitely interesting.
okay, so I was like in the beginning when I taught myself to program, and when I used Borland Pascal, it has a debugger, and this debugger has two modes. One mode is to go line by line through the code written in Pascal. And there is second mode, you can debug the program in assembly language. So because I play with it and I learned to read assembly. One of the fun things you can actually do is write to create programs that run fast. So this is like in informatics competitions, this is very important. So I had to learn all different techniques of optimization of a computer program to make it as fast as possible. And some of them had to do with reading the assembly language. So I was like very good at that at some point because I had a lot of practice and I also competed online internationally in the Bulgarian informatics and so on. And naturally, I was like more keen to jobs that require that skill. So those jobs usually had to do some real-time processing of information, video, I mean some large information. Or maybe they had like some kind of computer simulation of something complex that runs for hours or days or even months. So one of my very first real project jobs was in the university. I work in a laboratory that was called dosimetry and radiation protection. So what the people did in these laboratories, they did many things, but one of the things that involved me was they measure the radiation in certain places, like they leave a plaque, and this plaque stays for a while, and the radiation particles, when they hit it, they leave tracks. And after some period of time of exposure, you get this plate, and you put it in a microscope. Basically, there's some process that enhance the size of the tracks, but basically you select an area, let's say 1 square centimeter, and you take the microscope and start counting the scratches by with your eyes, and you count how many of them are like in the surface area. You take 10 surface areas, take average, and so on. And this is how they can measure the radiation. So it was like extremely difficult manual process, and the mentor at the time said, can you, if we take a picture with electronic microscope and I give you the PNG or whatever, the image, can you make a computer program that actually counts these tracks? So in nowadays, that would be like a computer vision problem. Back then, I didn't knew the term computer vision. But I said, okay, let's give it a try. So eventually we worked for a couple of months, and we actually, me and a friend of mine, Georgi Gerganov, we together we managed to develop this program. It's called Digitrack. So D is for my name, and G is for his. He likes to put G in his programs.
Yes.
So for the audience, this is the guy that started the GGML project. So we're close friends since high school. And yeah, that was very successful. So we actually managed to publish several papers. We automated the manual work in the laboratory.
Yeah.
And this actually increased the throughput of the how many measurements they can make in month, week, or whatever, because they don't no longer needed somebody manually to count.
Yeah. That's
The
very
results were
interesting.
like more stable because because there's different people that do the counting, and each of them counts a little bit differently. So what
Yeah,
they
like
did is
you mean
they
you have
actually had like a coefficient for each person that you have to multiply the answer in order to get the real radiation exposure. So if it's merely, let's say it's 1.05, it's for you it's like maybe 0.9, and each of these operators was like calibrated to the correct coefficient. I mean, yeah, this is totally legit. So that was like it was a real computer vision project. But I said back then we didn't call it computer vision. We call it like image processing.
Yeah.
Because you take an image and you process it. And,
Yeah.
I didn't know what neural networks were at the time, so we didn't use this approach at all.
So and I wanted to ask you, how did you, because that's very interesting to me, because you had a really practical problem, measuring hits on a plaque, and there was no good solution, or well, there was the manual solution, but of course we want to make it automated and more accurate. So what do you think, how did you use your past knowledge? And because this was, I guess, at least 10 years ago, right? And 15 years ago, maybe
2007, 8, this year. So
exactly. So
15 to 20 years ago.
Yeah. And back then, I can imagine there were not that many, frameworks, libraries, sites where you can literally, there was no ChatGPT that you can just ask brainstorm. So how did you combine different knowledge?
So we wrote it in Pascal. Let's start with that. So one of the bigger problem was like reading the image. So we were only able to read a specific type of PNG, But back then there was like specialized software for processing images, like there was something called ImageJ, which was written in Java, which had a lot of algorithms to, do some kind of background subtraction, some clustering. That was like a useful tool to experiment. Photoshop was available, which was also like, and GIMP was also. I never used GIMP before that project, but as I said, I saw other people use it. Anyway, there was not much available, so we basically wrote it from scratch. The PNG reading of the file, maybe we found it somewhere on the internet. And later we also ported the JPEG format with some library. We downloaded from somewhere. To be honest, I don't remember the details. Yeah, but was basically from scratch. And we did a lot of experiments. And we were like very light-minded. So we tried a lot of stuff that never actually worked. But the process was fun, like, and it was very specific because these tracks, they had like they're not like blobs of intensity. They have internal structure. They're more like castle. So they have like castle walls and inside tower. So this was actually what breaks all the standard algorithms. And this is if you plot the intensity.
Yeah.
Because it's a black and white image. So the physical processes gives you that exactly and sometimes those walls, they had like breaches. So some piece of the wall is broken for whatever reason. And our algorithm has to be robust to that, and also to big artifacts like because this surface, it's damaged from, for example, somebody scratched with a fingernail or whatever, it gets amplified a lot.
Yeah.
So
Very interesting.
to be honest, we were like with no theoretical preparation of any computer vision, and we just had the data and we play with it a lot. And it took us several months, so that was not a fast process, and we're like total amateurs. Yeah, nowadays I think the people are like hunting for the result very fast. So this is for me something that prevents them, like especially in the startup culture, when like you should fail fast and move on.
Yeah,
you can fail fast, but then what you happen typically in the companies, they change the product or the problem they're trying to solve. In our case, it was not like that because this was happening already in the laboratory. It was happening for years. So the people, they're like, this is what we do, this is what we measure. So if you guys can figure out how to make it faster, great. If not, we're doing what we already did.
Yeah. And for the indeed, I also find it interesting nowadays that there is this pressure probably coming mostly from startups, but I guess it seeps into other organizations to kind of deliver on things quickly rather than to play a bit more calm long-term game where you are perhaps more certain that you get positive results, but it might take a bit longer. And I don't think it's the healthiest environment. But maybe...
No, it's definitely not. So I remember there's like a very famous study performed by Google. So they were like, Google was well aware that up to certain payments, more money does not motivate people to work in their job. So they were like, okay, what we can do to actually motivate our programmers to solve problems more. And they throw a bunch of ideas, and they basically tested all of them, and they found that the things that motivate people a lot was for you to meet in person your clients and that you're going to solve their problem. So in our case, that were like the people that were like already in the laboratory. So I was like there like 2 or 3 times per week, and I constantly saw them on the microscope and doing this manual work, and I talk with them. And I mean, they were like okay with what was happening, because for them that was their job, they was getting paid and so on. But I was like, if we can solve this, that can really make their job go faster, and it will be like easier, and they can increase the throughput, which was important. So this was actually very mod. I didn't get paid for this job, by the way. I did it completely for free.
Yeah.
At that time, I was like happy to code and just solve somebody's problem. So
Mm-hmm.
I experienced that myself. And when I read the study, I was like, yeah, that's so true. Because in the startup environment, you don't know your clients. You cannot talk with them. I mean, and for me, that will be like super, let's say, important
Mm-hmm.
if you pick one specific person that you can actually talk life and understand what they're going through and how this is going to help them. So I can give you another example.
Mm-hmm.
A couple of months ago, I got some random call through a friend. Some guy, he was like, I have this warehouse. It's a big warehouse where they deliver some parts. I'm not sure what kind of parts, but they have inventory and they use these forklift cars to move heavy stuff around. And he said, like, I want to implement, to create a project that actually makes this automatic, so I don't have to hire drivers to do that. It's safer for them because they will not get injured on the job, and I can save money and so on. And I was like, okay, let's go with this idea. Let's see what can happen. So I started asking him questions. And when we reached to the point of pricing the project, and I was like, okay, let's say this project costs you 10 million to develop, which in my estimate was a reasonable amount to say. And you're only going to use it in your warehouse. Maybe it's cheaper to hire people to do that for the next 10 years. Can you do the math? And he was like, yeah, it's cheaper to, to hire people. But I was like, okay, so if you cannot resell it to other warehouses, you can do it, but we'll be like throwing money away, basically.
Yeah.
And he thought about it and he said, like, yeah, you're right. And he decided not to go to this project because he does not know how to sell it to other warehouses. And the solution will be like very custom to his specific setup because he has like a legacy, like it's 30 years old, and it's not something that we design from scratch and we can replicate in other places on construction and then we can resell the software. So it's different story. And I imagine if we went through without having this conversation, eventually he will figure this out, maybe on the 3rd month, on the 5th month or whatever. And he will be very unhappy and this project will fail. So this is something that for me it's very important to understand what problem are people solving with AI. I mean the clients. Because usually they have other problems. So what usually happens is for people that don't understand AI, for them it's a magical thing. So it's like this magical thing that solve your problems. And they start to daydream about how this works. And eventually, if we find the ML guy who can do the magic with the computer, that will solve our problems. And when they find me and we talk, often I realize they don't have problems that can be solved with AI. They have other problems. They have organizational problems.
Yeah.
Maybe they have some problem that can be solved with a web page without AI. Like my accountant, he's very keen on AI. He was like, we should include AI in accounting software. And I was like, dude, you're doing accounting. It should be deterministic. It should be predictable. There's laws how you should do every step on. I mean, it's so you have like accounting is like something you already have like legal specialization of what you should do. there's no creativity there. You don't need a creative accountant. That's basically you're putting 1 feet in the jail with that. If you have a creative
Some people do.
Some people do. Yeah. But I mean, what I realize is that people, they don't understand the depth of it. They're like looking at it as like a universal solution to the problems they already have. And they don't think how we can solve this.
Yeah, and oftentimes I think it's because it's a combination of maybe a few things. First, AI is obviously very hot and people mention it all the time. Second, these people who just try to solve it with AI are perhaps a bit lazy to think more fundamentally what their problems and goals are. And third, there is maybe some kind of external motivation, or in the sense that if you have AI that's good for marketing, or people will think you're smart or
Get
cool
the
that you're
marketing
doing
speed
it.
there. Yeah. I understand that. So as I can recall, there's like, I'll keep this anonymous, but one of my startups that I worked for, there was like, they were pitching their idea to investors, and the investors were like the venture capitalists. They're like, okay, we'll give you the money, but if you put AI into it. And there was like, there is no need of AI. I mean, it's because AI is complicated. It's undeterministic. It's probabilistic. I mean, sometimes it works, sometimes you don't. And as I said, if you're doing accounting software, you want it to work every time. You don't want to work half of the time. So it was like completely artificial, but they said, this is one of our conditions. And you also have to hire AI guy. And I was like, and they were like, okay, if that's the condition, we'll do that. You give us the money, we'll do whatever you put as a conditions. And it was completely artificial. So it was, in my opinion, waste of time and resources. And I was hard to do that. So eventually it was like just to make the investors happy, know. Yeah, so it was, but it happens, and I see it happen at some point of time. It's like on every startup. I mean, not just the ones that I work for. It's just even the ones I interview. People tell me like, yeah, we're funded by these venture capitalists and pre-seed, whatever seed. And they say like, but they want us to do AI, otherwise they will not give us money. And people doing all kinds of startups, they're like, no problem, we'll brand ourselves, we just put AI there and whatever works. And now with chatbots, because chatbots are very easy to integrate. I remember a couple of weeks ago, I went to my bank, and basically what I did is something I do like once a year, converting some loyalty points to money. They switched from web platform to AI bot. So now you have to use the chatbot to do that. Which for me was like, okay, you had the buttons that work. You paid somebody to do this migration, to go through the chatbot. For me as a user, it's more inconvenient because I don't type fast on the phone, so I have to chat with this bot on the phone only. I cannot use it to the web browser, and it was like, basically, you annoy me. You're not solving my problem. And my guess is that they never talk with their actual clients. They're like, we should put AI to be fancy, so our clients of our bank know that we're fancy for whatever reason. I don't know. So it can definitely backfire in terms of client satisfaction, because I was like, should I migrate to another bank? And then I think, the other banks do the same stupid shit. So there is no point to migrate it from this to another competitor, because they all integrated chatbots because it's fancy.
And
My
this is
guess is
also
they will drop them in a few years. This is just a guess.
Oh, interesting. Well, maybe we can go on this tangent. But I also wanted to mention that again. I like how you're thinking in the sense of whether a feature or a part of the business makes sense for the end customer, the end user, and that as somebody who as an employee or part of this business, you should always be putting this customer first. And many companies are saying this, right? Like the customer is king. They're our top priority. Making them happy is what we're here for. But it's definitely right. It's the right mentality to have. Not just say that, but really have this. So that's very good. I think a learning point.
Yeah. So as I say, when you go to interview with company, you don't know. They usually present you a list of values.
Yeah.
That they claim they have, and when you work there for a while, you realize there is another list of values they actually do. So what you're saying is like it's good to actually do that, not just to brag about it. Yeah,
Exactly.
I get that. So, and while I'm saying they're going to drop this, because chatbots are very actually neural networks, they can be subject to attacks. There's like adversarial attacks. It's a whole theory how you attack a neural network or whatever algorithm there is to produce the results you want. So I think what happened, I'm not sure if this is the correct company, but let's say it's a Toyota. They produce cars, and they introduced a chatbot as their like customer support. As somebody that understands this theory actually hacked the bot and submitted a complaint, and the bot, after certain prompts that were like very specially designed to to hack it, promised that they will give you a free Toyota as a compensation. Yeah. And then this hacker went to the official Toyota channel and said, your customer support said you'll give me a free car. And it's official because their like email is considered like official communication. If they refuse, he can pursue a legal action. And probably he'll win. I'm not sure what happened at the end of that story. Maybe they agreed for a huge discount, or maybe they actually gave him the free car. But these systems are like very easily, not easily, but they're hackable. And if there's enough reward, people will go through the struggle to do it. So, and I think this knowledge will, get more and more spread over time. So eventually, businesses that don't actually benefit from this flexibility, like banks, I mean, web forms work fine for banks. There's no need to overcomplicate stuff. Yeah.
Yeah, that's a valid point. I think a lot of them are also doing it maybe to unlock as an opportunity for future growth. Perhaps there is something that this would unlock some unknown possibility, and maybe this is justified, but indeed the cost is short-term customer dissatisfaction.
So I don't know anybody. This is maybe I'm living in my old bubble, but I don't know anybody that can use chatbot and it's bad with web forms. So, for example, my grandmother, she cannot use any of them. So she can only use paper and pen. And everybody I can think of, most of the people are like very good with web forms and filling stuff. And not all people I know are like good with chatbots, because it's something you have to learn. So if let's say you and me, we spent a lot of time in the computer console. So we're like used to, typing to the computer, reading the answer, correcting, adjusting, and so on. But with people, let's say from the generation of our parents, the interaction it's not smooth. It's not easy. And they get frustrated and they quit.
They call you.
Yeah, they call me sometimes.
And so one of the things, so you mentioned, I think 10 minutes ago, but I wanted to ask you, so you shared this project that you did in university that I think was pretty interesting, and you actually did not get paid to do this. So I'm wondering, what are the career prospects for somebody who likes to work on such low level problems and algorithms? Is this like maybe if you have advice for kind of like younger people or people who want to work more on these things, is this a good career to have, or is it a bit well, maybe you'll get satisfaction but you'll not get paid a lot?
So it's very niche, that's the thing. So it's so imagine this: if you can optimize Facebook as a site by 1%, you're saving 20 million to the company per year. So that's a huge benefit. The thing is, there is like Facebook already hired the top 100 low level guys in the world, and they spend their years optimizing Facebook. So and there is not easy optimizations there. So this could be like a very, very beneficial, but it's very niche. And the thing is, when you're like working in a very niche environment, you don't have that many options to pick. So let's say in Sofia, there's like quite a few companies that can actually benefit from this skill. And I work in all of them. And in my understanding, probably it will never appear again. Because computers get faster and faster, they get more cores, and people now just throw hardware at the problem. Actually, they did this in the past as well. So, but it's getting easier just to increase the hardware. And what happened with mobile phones is because they're like battery powered and they have to be energy efficient. There was like very huge opportunity there as well. So if you're going to do some kind of complex computation on such a device, there is like very good opportunities. But even there, it's what people usually do is they use low-level libraries that already solve this problem very fast. And there's years of very specialized work on that topic that you can just reuse because most of them are open source. Yeah, I can basically tell you like very interesting story. There is a library. I'm not sure if your users are familiar, but it's BLAS library, basic linear algebra. I don't remember what stands for. But basically you can multiply vectors and that's it. Dot product and so on. And there was a version of this library called Goto BLAS. It's written by some Japanese named Goto. It's Goto BLAS is the fastest up to 2 processors. So on every benchmark, he's the best until you get 3 or more. Then he's not. And it's a handly optimized assembler. So the guy actually optimized the assembly code by hand, not with the compiler. So compilers are extremely good because they get like 97, 98% of the performance of Goto. But yeah, so this is example of somebody that's extremely skilled. And maybe somewhere in some company like that is big, like Google, Facebook, that uses a lot of electricity, they can benefit from that. But if you're working in small startup, there is no, probably you're not going to benefit in any meaningful way from this thing. Just as long as you get the algorithm right and the computation complexity, you're good to go.
Mm-hmm. Yeah, so it's for these more low-level tasks, it's difficult perhaps to get a lot of jobs, and yeah, it might not be the best career in a conventional sense, but yeah, if you want to do it, there's still some areas to do it. And of course, I think now perhaps with AI, there are new areas that need to be explored and optimized. There are a lot of we briefly messaged before this meeting. There are a lot of investments going on into data centers, into GPUs have been getting hotter and hotter. And
I think AI has a lot of this could be like I can talk about this. Are you familiar with GGML?
I know the library. I've seen it. Haven't used it too much, but yeah. But you could perhaps explain it a little bit to our listeners.
Okay, so I'll give an introduction. So GGML is a library that actually performs the computation for large language models using the CPU only. And it does it much faster than the GPU. And initially that was paradoxical because people are like, yeah, GPUs are faster. But what actually my friend George realized is like you're multiplying vectors by vectors and most of the entries are 0. So he was like, if I can compress this representation and perform it on the CPU, it will be faster because the individual operation will be slower, but the combination of those two will be faster. And because on the GPU, it's not easy to do conditions. So if statements are expensive and they usually are represented by some kind of multiplication by 0, something is, I mean, you pay for both branches. So if there's like if then else branch, you do the both of them simultaneously and you just throw the unnecessary result. So he performed some kind of prototyping and yeah, that was indeed faster. So he then realized that he can do other optimizations on top of that. And his GGML library is so much faster than the GPU ones that actually nowadays most of the at least small scale chatbots use that. So there's like one guy in his basement in his free time, he managed to beat Intel, Nvidia, and so on, Microsoft, all these companies in this specific, just because he realized at the low level how it works. And this is like very incredible success story. And it comes from this knowledge because both of us did this low level optimization stuff in the past. And actually many old school developers also did that because especially in the 90s, there was not much to do. The internet was not around. So most of the people I know that are like old school developers, like they have like 30 years of experience. At some point of their life, they're like read assembly, they wrote optimizations and so on.
So your friend George or Georgi, now if you've built such a innovative way to use I guess neural nets and do this just on the CPU rather than using the expensive GPU, are there any, like, I guess there could be a lot of possibilities to turn it into some bigger, more commercial company. But at the same time, I can imagine that I don't know him personally, but he's more interested in the technical side of things.
Yeah,
So
he's exactly that.
yeah. So yeah, how do you is this not a good opportunity to do something bigger? Meaning, if you're such a person, like I think you perhaps have a more economic way of thinking, like you see things in the bigger picture. So is this opportunity that you could take?
So most of the majority of AI products are not economically
Mm.
beneficial. So
Mm-hmm.
as I said with the forklift guy,
Mm-hmm.
for him it might be like super expensive to do that as an AI project. It does not make sense from a business point of view. I mean, for me as a developer, I would very much like to do that and get paid for it. I don't mind that, but basically we're burning his money.
Mm.
So if you think of it from this perspective, then there are quite few applications that are like that make sense, and most of them have to do with military applications, intelligence operations. Like, for example, they listen to your, let's say, some agency with 3 letters. They listen to your chats, and they use some chatbot processing to derive intent, and maybe they identify some potential terrorists or opponents of the political regime or whatever. Yeah, they can. That's one area of like, because it has this scale and this mass, can make sense to do that. But if you go like a little bit on smaller scale, then it loses economic sense to even attempt to do something like this. Okay, I can give you another example. Let's say I have a friends that they have roses in Bulgaria. So they tell me like this: it's they have these rose fields, and they pick the roses by hand, and they condense them, and they produce rose oil, which is something that Bulgaria is very famous for, and so. So they say, like, every year there's like less and less people willing to actually do the physical work, and we pay them a lot, and still there is not enough people. Can you develop a robot that does that? So robotization of agriculture is something that is happening, and it's happening a bit slow, but it's definitely happening. So, and I was like, okay, let's say we develop this robot, and you will basically have to, pay and so on. And what will happen is then you have like overproduction of rose oil because you will sell it to the guys in the Morocco, to the Turkish people, and everybody in the region that also has a lot of roses, and they also have the same labor shortage problem. And you basically oversupply the market with a lot of rose oil. Maybe that's a good idea. And the Chinese, who also produce roses, they will like probably get that, will copy that technology and improve on it. And they will definitely oversupply the world market.
Yeah.
So you're digging your own grave in a long term.
Yeah.
And they were like, we never thought of that. And yeah, you'll pay the initial investment. So eventually somebody will do it. This is my guess. And the companies that actually have interest to do that are the buyers of the oil. So L'Oreal Cosmetics or something like this, the big cosmetic companies that they're like the consumers of this. They're more interested in developing the technology to make their resources cheap than the actual producers. resource. So I was like, if you want to do that, you should go to them and pitch them data to pay for it. And maybe you can get money. So this is like, also there's like other agriculture projects like health check of chickens. That was something very interesting. So there's like AI computer vision that actually takes a video of in a chicken farm and pinpoints some of the chickens that are sick and they're about to die, or they're very sick. And the idea there is to separate them and they don't spread some kind of disease they already have to other chickens. And so on. So there's like many applications that make economical sense, but they're usually in production environment. They're usually in something that most of the people day to day, then they don't think about this stuff. The chicken problem was like very, I eat chicken every day, but I never thought that some of the chickens may get sick and they basically spread the disease to other ones. And this is something like people that grow these birds, they usually find out when there's like already like maybe 20 or more sick animals. And to be able to identify that early helps you a lot. So the successful stories I know are somewhere in production, something that is not commonly known. People already had this problem, and AI somehow cheaply help a little bit to improve the efficiency of what they already do and what was already economically successful. So it's not like I cannot think of successful economically company that does only AI and does not have like military application. Let's put it this way.
Yeah, which is also not something that gets talked too much about in the public. At least I don't see it, in videos or posts or just people talking about it. But for sure, it must be happening, right? But under a veil of secrecy.
Well, I don't think it's okay. So, have you heard of YOLO model? You only look once. It's a very famous model for object classification. So you can basically, you give him an image and many classes, and he identifies the objects in the picture, and he draws a bounding box around them. He can even do like pixel segmentation and so on. Maybe if there is like a screen share, I can show you what I mean. But there is like different versions of YOLO. It's like YOLO 1, 2, 3. I think the latest is 9. Maybe it's even more than that. So the thing is, the original author of this approach, which was very clever, and I really like his approach. After version 3, he wrote a public statement that he will no longer work on this project because he has moral issues with its military applications. So this is not a statement from me, I'm just quoting him. And I use it to process satellite photos. So it's very easy to imagine if, let's say, you're like taking pictures of the Earth from satellites, because you already have a lot of satellites for, let's say, USA, China, whatever, India, and you process them with this algorithm, and you can identify interesting things your opponents do on the ground. Like, for example, prior the invasion of Russian invasion of Ukraine, the Russians built a lot of field hospitals near the front lines. And this was visible from satellite. Obviously, if you do like mobile hospital detector on such images, you can figure out where the actual intent or capabilities to attack is. And this is like very silly example, but if you combine these methods with other means of method of intelligence, then you basically have very powerful. Otherwise, people have to do this by hand. And
Like
I was
looking
like,
at the pictures and
yeah. I was like, it was a joke from from my father that actually it was from my uncle that because he was like doing a military service in tank division.
Mm.
And they had to hide the tanks from the sky because there's like satellites taking pictures, and the enemies will know, the Turkish will know, where our tank is located. So that was very silly for me, but nowadays they do know where. They actually do. I'm sure they do. I mean, if I can do it like in a month in my computer, then I'm sure those guys already did that.
Yeah. Maybe to go on a bit of a tangent, actually, one of the very interesting things about you is that you are, what's the word, ex-member of the parliament in Bulgaria. So
Yes.
you had some exposure to decision making. One of the things I was interested in is, generally speaking, of course, without giving any sensitive details, how are decisions being made at such a high, at very important for the country place? Is there some sort of a probabilistic thinking or data-driven decision making, or is it mostly kind of I give you this, I make you this favor, then you give me this thing? How does it
So
work?
when it comes to our industry, because this is the context we're talking, so you have to imagine it like this: where the very important decisions right now are made by very old people. So we're kind of, and this is property of the system because of the majority of the voters are old. Also, the majority of the political leaders are very old in Europe, not just in Bulgaria. So all of them are part from the baby boomer generation, so-called. Even our famous Boyko Borisov he's also a baby boomer. So those people, they're very reactive. So the thing is, if you look at people by age, very young people, they're like, let's do a revolution, let's change this, let's change that, we don't like this, we're going to change it. The young people, they don't see the price of the decisions they make. So they only see the benefits, but they don't see the cost. That's why they're they're willing to do stuff. They're willing to tear up a system that has some drawbacks, but it provides benefits. And the middle age, there's like the party I was part of, we had like a middle age mindset, which was like, let's change the things a little bit and see what happens. So no sharp moves, nothing like radical, just slowly pushing the country in the right direction and be patient. And the old people, they don't like change at all. They only do any change if it's necessary. They're totally reactive. And they lack strategic thinking. I mean, they have strategic thinking in how they can keep themselves in power. That's something they're very good at. But if we exclude that, they're not visionaries. They don't want to, let's say, optimize the bureaucracy so it will be more efficient. For them, they don't benefit from that. They benefit from the exact opposite, because then they can arrange friends and family to work in that bureaucracy. So it's like a cancer. So the bureaucracy is like a cancer that spreads and eats the whole system. And eventually they reach to our field because and this happens mostly in the European level. So there's like regulations what you can use in your AI models, for example. And those regulations say like you cannot use sex, gender, I think ethnicity, and so on, because this sounds good on paper. And I'm just like, okay, but how you can verify that? I mean, the colleague that is on the next desk, he does not know what I'm using. So, I mean, if I can get the data and use it, there's no way they can catch them. Even if I give them all the code, even if I give them everything, as long as I don't name the variable or the feature gender, sex, and race, then it's okay.
Yeah.
I mean, they're that stupid. So,
But
I mean,
this
not
is,
all
I
not
think
all
what you're
bureaucrats.
talking about is probably about these would be algorithms that are used at a very global scale in a country or in a
Yeah.
ministry to make decisions. And the point is to not use these factors that can be used to discriminate one individual against another one. Even though
Yeah,
there
but
could be genuinely useful, it's against, let's say, ethical considerations, right? This
yeah,
is
exactly.
what you're
So
talking about.
I can give you a more specific example. So, you know, these companies that give loans to people. So what they found out is ethnicity is a good predictor of will you repay the loan or not in Bulgaria. So because we have like a couple of minorities, and one of them it's not very good at repaying their loans. For listeners that are familiar with Bulgarian context, they will figure out what I'm talking about. But the thing is, there is like European directive that forbids you to build such a model with AI. But traditional companies and banks use it because they're like subject to a special law that says cannot disclosure what we're actually using. But trust us, we don't use ethnicity. We collect this data, but we don't use it. So it's, I mean, for me, it's obvious they use it. I cannot prove it, but I'm sure they do.
It's difficult indeed
Yeah,
to be sure they don't.
This is like the current state of affairs, but so it's like we have regulation, but it's only on paper. And what is actually used at some point, let's say these European politicians, they want something from this company, mostly like taxes or donations to their party. And they basically say, you know, we have this regulation and we know that you're not applying to it. So please make a donation to our party and we'll not talk about this in the next few years. And they make donations to every party, basically. And this is how they finance some of the political parties. It could be like donation to the party, or maybe it could be like some kind of personal bribery. That's for corruption.
Yeah.
But this is what it happens. That's why I'm against it. It's because it's something that you cannot easily control. There's no point of regulating it. So obvious example is speed limit on the road. You can put cameras, they measure speed, you can control that. It's very easy to actually apply the speed limit on the highway if you want to do it. It's not easy to apply what features you use in your AI model. So you should never do that. So from legislation point of view, but it's convenient for corruption practices. So when they pass legislation like this, for me, it's obvious what they're doing it for. So, and they always say like, we want to protect the people. You know, it's a bullshit. They want bribes and donations to the party. And this applies to every party. I mean, it's not one concrete that I'm having in mind.
Yeah.
So this is and also on European level.
Exactly.
And it happens in many industries. Basically, the AI is the latest industry that, and even happens on a large scale. I remember a couple of years ago, and I think even happened this year that like European Commission threatened something about Facebook, and if you don't comply with our regulations, we will shut down your platform in Europe. And Mark Zuckerberg knows how much money he earns from Europe. And to be honest, if I was in his place, I would just, threaten them back like, okay, I'll shut down it for you. And then the governments will fall, because I'm not sure if you're aware of that, but whenever somebody shut down Facebook, it leads to revolution. Nepal is the latest example. So there we have like the so-called Gen Z revolution. The actual trigger was stopping the social media of Gen Zs. Like because there's they spread too much corruption videos of the elite, how they live, where their children go, through TikTok to Facebook, Instagram, and other social medias. And this led to protest. And what the Nepal government actually did was they decided, okay, let's censor all these platforms so they can no longer share the corruption videos of what we do in our private lives. And you can see images of these horror stories that actually happened. And like there's like people burned alive and basically riots, a lot of victims from the political elite. So basically they committed seppuku by doing that.
Yeah.
Arab Spring was the same example. So in Egypt, the revolution started when they stopped Facebook. So it's very politically important. And nowadays, all the, let's say, modern politicians use that as a platform. So, for example, the most popular nationalist party in Bulgaria, they're extremely good at that, using Facebook to advertise themselves. They exclusively do that. It's hilarious. Like they're nationalists, but they're using like American platforms to do their political. And they're actually, I know some of their very keen supporters, and they're good people, by the way. Some of even their members of parliament, some of them are like very nice and good people that are trying to do good. So I don't agree on many topics with them, but yes, I give them respect for using the modern American platforms to broadcast their message.
Yeah. So it's such an interesting interplay between politics and technology.
Yeah, I mean they're very separate. I mean, there is a series of revolutions called the gunpowder revolutions. So basically, the discovery of gunpowder led to development of, let's say, muskets, and cannons, which basically made the European knights and all nomad armies obsolete. So this is like one technology changes the world by shifting the power from one side to another. And I believe artificial intelligence is such technology. So it shifts power from one side to another, because power, it's not always in one person. It's always a little bit spread. I mean, some people have more than others, of course. So, for example, Boyko Borisov has much more political power than, let's say, me, for example, or maybe any other person in this country.
Maybe just for any international listeners, Boyko Borisov is it's a leader in he's a leader of the biggest party in Bulgaria, and
Yes.
he's ex-prime minister a couple of times, and he's still a very prominent and controversial figure in Bulgaria.
He's also like used to be in many roles in the politics in the past, but he's very influential. So maybe we can say something like, let's give an example of Barack Obama. He's not an acting president right now. His party is not controlling the Senate or the presidency in the United States, but still they have a lot of power there. In many decisions, they have influence. And he's part of a certain clan in the Democratic Party. So every party has its internal fractions. So there's like, if you have like 3 people in party, you have at least 2 fractions. So
it's a nice way to put it, indeed.
Yeah, so it's like this always. So
one of the other kind of just brief topics I wanted to touch on, and it's a very practical one, is whether you use LLMs as a developer, and how does it play in your kind of just programming workflow?
Okay, so it's like I tried using LLMs, and I see they have like how to say it. If I'm starting something from scratch, they're extremely powerful. I mean, especially if it's a language or technology I never used, then it helps a lot. But if it's something that is a bit more mature, let's say a project that is already started, it has several million lines of code, and you're trying to fix this one thing, and then I don't find them helpful. So it depends on the maturity and on the size. So, and what I also noticed that sometimes these chatbots, they introduce bugs that are very hard to find. Basically, the time you save is usually offset by the time you debug and fix the problem later. And I'm not sure how much it makes sense. So in a production code, I try to avoid it. But as a prototypes and learning experience, it's definitely very good. I'm not sure I tried the best ones. Basically, I tried with free ones because I understand that there's like a bunch of paid services that people claim are extremely good, and they use those compared to the free ones. Maybe that's the case. Maybe it's not. I don't know. But for me, coding, it's not so if you use this chatbot, you basically accelerate the coding part. For me, the coding part is not the slowest part from the development. There's no bottleneck in coding. So let's put it this way. The bottleneck is somewhere else, like code reviews, user definition requirements. So when you develop software, usually your clients or your users, they have no idea what they want. So they ask you to build something, you show it to them, they say, but we didn't want that, we want that. And when you give them the product, they realize, okay, we were not precise enough of defining what we want, because this is what you built and it does not do that. Maybe do some extra. I remember a couple of years ago, I was talking with one of my CTOs, and he was like, just write some program that does not crash. And I was like, okay, and I passed him a hello world in a few seconds. And I was like, this is the program that does not crash. Go to the director now with it. He was like, you're fucking with me, Ness. Of course I'm fucking with you, because you give me like such a vague definition of what I would have to do, that you deserve that. So that's how we usually communicate on a low level, It's basically junk in, junk out. But it's very hard to give like a precise definition to the developers what they should do, how should they build it, especially when there's like these intermediate branches between the problem and the client, the problem, the management, and then the developer.
Yeah.
I don't know why there is like a stigma of developers talking with clients directly. I see some companies avoid that as a plague. I do it like in my career many times. I like talking with clients. Yeah, some of them waste your time, definitely, because they don't know what they're asking. Or they're basically in the wrong place at the wrong time and they're dragging you with them. So if you know how to cut from those conversations early, then you're good to go. But otherwise, they can drag you days and it's not fun for anybody. So as I said, they can be useful too. If you don't know how to code, and yeah, go for it. It will get you started. I think that's the most important thing, to get you started. Because I see this in YouTube, I get these recommendations like build this app with no programming experience, start a business and whatever. I was like, yeah, because programming is not the important part of business. It's the sales channels, the problem you're solving, the company you have, the people that work for you, or maybe you're solo, whatever. They're much more important than the actual code. I remember some companies, they're like, they have like completely open sourced all their software they're writing. It's free on GitHub, you can download it.
My company right now that I work for, actually, almost all of our software is open source.
That's because they have other mechanisms of controlling the ownership. For example, the sales channels. So everybody can copy your code. But if they don't have a channel to find customers and sell it to them, they cannot do anything with that code. That threatens your position, basically. So that's why you're like, okay, we open our code and everybody can participate. And you can even make the hiring process like, if you want to get hired in this company, you should submit a pull request in GitHub. This is your application. Find an issue from the backlog, figure out how to write it, create it, push it, submit it for review, and now you're applied for a job in our company. I mean, that's like a super valid process to hire people, and you don't waste internal resources with shitty candidates. You don't waste resources with agencies that bring you people that you talk with hours and then nothing happens. And yeah,
for sure. And I think we've covered a lot of topics. Is there anything that you wanted to kind of specifically talk about in this episode? Or do you think that's probably we've covered? Because we did cover, your university years, low-level computer vision algorithms or image processing algorithms, as they were called back then. We covered some kind of economics and machine learning way of thinking and stuff. Some politics as well.
Yeah, some politics. Well, I don't know, maybe something I felt. So let's go with this one. I tried a couple of years ago to develop some kind of artificial intelligence algorithm that that trades on the forex market. But it's the same for stocks. And it turns out you cannot do that. I mean, I cannot do that, but almost nobody can do that. And there's like a very good fundamental reason, because this kind of the stock market and all these public traded markets, they basically are internal analyzing. You have a different independent players that put trades and so on. So if some strategy works for a given period of time, then the others adjust to it. So it's like, it's a metaphor of war, basically. If you consider it a zero-sum game, then it's a war, because whatever you lose, somebody gains and so on. And I didn't realize that at the time. So it's like, there should be like a mathematical function that describes this in time, but it turns out there is none. And there are fundamental reasons for that. So if some of our listeners are willing to try this, go. I mean, this is my experience. Maybe you can prove me wrong. And I know some people actually manage to make money out of these strategies, but what they do is when they're successful, they keep it for themselves, and they stay at like not very low volume, but basically they don't go advertise and sell to billion of people. They're successful AI trading strategy on Bitcoin or whatever.
Yeah.
And this should give you the hint, if somebody sells you that, probably he is lying. It's another good takeaway from this experience.
Yeah, definitely. So be careful to not go into zero-sum games, playing with bigger players, especially.
Maybe you can go. I mean, there's like, I think Warren Buffett said, usually when there's like on a poker table, there's like people with skills and people with money, and usually when they sit together, the ones with the skills get the money, and the ones with the money, then they get the skills. So
that's a good one. Good way to put it.
yeah, so there is exchange of a different kind of
yeah. So the losers should not feel like they are kind of giving up money. It's actually they're paying for education and fun.
Yeah, that's the thing. It's I think this is something I learned from the computers, because if you think how we were educated in school, we're educated as like this is the authority figure, usually the teacher or notebook or whatever. They give you some information, you take it and carry it in your brain until the next day or next week or whatever, end of semester maximum. Then you spew it out, you get a grade, and you're good. This is what our educational system basically does. With computers, it's different, because you don't have authority figure, you have a computer, and you can write programs and test them, and gives you like feedback. It's actually testing against nature. I mean, it's computer experiment, but still it's experiment. So you learn to try things and learn from your mistakes. This is the thing. It's like, I tried this. If you want to build something, usually you're like going to fail multiple times. And at the end of the day, the faster you fail, you're like, your code does not compile, you fix it. Your code does not compile, you fix it. At some point, you don't even consider that a failure. I mean, when I initially started, I was like having problems with that, but now it's not like this. And I remember I was giving lessons in programming to a friend, and it was back in the university, and it was a girl, and she was like, I'm scared my code will not compile. And I was like, that's the point of it. That's why you have a compiler. It's like and she did not want to compile the code, which for me was like, and she was studying for a grade basically. So that's why it does not work with this mindset from school. You have to do the other mindset, which is like, how I can figure out this thing? What test should I run? Who should I talk with?
Yeah.
Like, let's find a client. So, for example, if you want to build a reservation system for a yoga studio or whatever studio, and you should find your clients, you should talk with them. You should say like, hey, do you have such a system? How much you pay? Are you happy with it? Is it good? Is it bad? I asked the notary. So I went to the notary here a couple of years ago to basically sign some documents. And you signed up, you have to basically call on the phone and somebody picks. And I asked them, why don't you have a website and a reservation system for your clients? And they were like, no, we're used this way. And I was like, do you want me to develop one for you? It will cost you that much. And they refused basically. But I said, okay, you can find somebody to do it cheaper. I mean, for sure. But you can do that. And then this girl that answers the phone can do, by the way, she graduated law. So, and she works as a receptionist basically. So she can do like more meaningful stuff with her time instead of being just picking the phone and writing names on a paper. So this is how you approach this kind of problem. You basically interact with the environment, and the computer is very good in environment to interact with.
Yeah.
Basically.
Yeah. You should just try to take action, not be afraid of failure, and see where that takes you.
Yeah.
And I think that's actually a really nice point on which we can wrap up our conversation. I think today we had, as I mentioned, a very wide range of topics that we covered, and I'm sure our listeners would find some nuggets of gold in a lot of them. I for sure did. If there are any final things you would like to say, maybe if for our listeners can kind of follow your work anywhere, or perhaps your business services, feel free to mention it.
Well, I have a LinkedIn profile, but I'm not very active there. Usually when I open it, there's like a bunch of requests there and I just ignore. So I don't share my work publicly. I mean, I have 2 GitHub accounts, but I use them for work that I get paid for. So I don't have any open source project of my own that I'm currently working. I have Facebook profile that I keep semi-private. I mean, I try to just connect with friends from high school and some personal stuff. So, and YouTube, I mean, you can Google my name in YouTube and you'll find some of my podcasts and lectures. And I participated in the past on various topics. But nowadays, what I see is the social media has changed because back in the days, it was like looking what your friends do and so on. And now it's more like niche focus. So if you're interested in one thing, let's say mountain biking, the algorithms detect that and they show you a lot of mountain biking stuff. And what I try to do is I don't have like specific niche. I appear in different topics, in different contexts, in many over long period of time, over years. So that's why I don't have any popularity, or I actually don't plan to develop any popularity at all. And I don't expect it to happen. I even have a YouTube channel that is very how to say it. It's for my friends. It's not for the audience. So the videos are private. I use it to share some videos with my friends. I left some private ones just for fun, also some public ones just for fun, and that's it.
That's totally fair. Totally fair. In a world where a lot of people try to share as much as possible of their lives on the internet, you don't have to do that. So
I don't try to be an influencer. That's a full-time job. I respect them for that, but I'm trying to do other stuff.
Amazing. Well, thank you very much for taking the time today. I'm sure we'll have opportunities to talk in the future. And so thanks again. And for our listeners, until next time.
Yeah.
Bye-bye.
See you. Have a nice day.
Thanks for listening to the AI and ML conversations with myself, Yavor Botev. If you want to support the show, please subscribe to the podcast on YouTube. In addition, please follow the podcast on Spotify and Apple and share it with the people you know. Thank you.